So in this video, I'll be going over topics 1.13 and 1.14 of AP Pre-Calculus. This is not going to be the note sheet, and instead this is going to be the worksheet that I'm going to be going over, because why not, you know? And so this calculator right here I have open is just a random website that I found, because I don't know how else to access TI calculator specifically on an iPad, so I'm using this. You can see my cursor to see what I'm going to be clicking. So let's go. This is on modeling and applications. So this topic is mainly just know how to use the calculator, and there are some things that you need to know, and we'll get to that. Alright, so the first problem. Justin Tucker, the kicker for the Baltimore Ravens, is considered one of the greatest kickers in NFL history. On a recent kickoff, the height of the ball in meters was measured for selected times. This data is shown in the table above right here. So this is the X, I'll write it on the other side. This is the X and this is the Y values. So based on the situation, the data presented in the table, would this be a linear, quadratic, or cubic function be most appropriate to model this data? Give a reason for your answers. Okay, so is it a linear, quadratic, or cubic? On the notes sheet, it told you how like each one would be like, because it is say like linear is like usually talking about constant rate of changes, while quadratic is like linear rates of changes. Also constant means like it stays the same. Linear is like going up the same amount roughly, you know, it's an estimate. Or so quadratic actually has three kinds, and then it has a symmetric with one single maximum, or the word problem involves area. And then for cubic it's involving volume. So there were a couple word problem examples in the notes. But yeah, so if we look at the table in this one right here, we see that, okay, it keeps increasing, 9.6, and then it's going down. So clearly this right here is the max. So it looks like it's like going in a quadratic. This right here is the single maximum it has. So it's a quadratic, most likely a quadratic. And because I'm just gonna quickly write this, because it's a little messy. It has, or it increases to a maximum, a max. It has one max. And then we can also see that it's roughly symmetric. This might be a little bit different than that, but yeah, it seems like it's also roughly symmetric. Has one max and is symmetric. Yeah, it should be something like that, you know. So yeah, it's a quadratic. Then find the appropriate regression for this function. So now we're going to be using the calculator. So what we want to do is click alpha, then stat, to get into our table to enter the values. Make sure you're on edit and then click enter. And now it's giving us columns. Each column is going to represent the X value and Y value. So we're just going to use L1 and L2 since we only have two, our X and Y. So L1 is going to be all the X values. So we're going to go ahead and enter them. So the first one is 0.1. And then click enter, and then just keep doing that. Alright, now that we have entered all the values, we want to go back to alpha stat, and now go to the calculator tab, next to edit, and then go down into what we're trying to use. We said that it is a quadratic function, so we're going to go with number 5, which is a quadratic regression. Click enter, and then we want to go down to the fourth row, which is store regression equation, and then click alpha trace to get to get y, and we're just going to put y1, and then go down so you can calculate this equation or function. So I'm going to click enter, and then there you go, it gives you the equation, and that's what we want to write down. So y is equal to, and then for pre-calc you want to round to the to the thousands, or the third number, so negative 4.9147 goes to 5. Or oops, I forgot the x squared. Make sure you add those. Plus 13.71, 38 rounds to 4, and then x plus 0.0695 rounds to 10, and then so the 10 makes the 6 a 7. Okay, that would be our equation. And now C, using the model found in part B, what is the predicted height in football in meters at time is equal to 1.3 seconds. So time is that x value we see here, and so we want to alpha trace, which is how we got the y's stuff. We're going to use the y that we used the y1, so we're going to click on that, and then parentheses the number that we have. This right here is only going to work if you're asked to find the y and you're given that x value, because t is an x value. If you're given like h of t is equal to something in meters, then you're gonna have to solve that on your own, not using the calculator. Like if h of t is equal to 5, then y right here is gonna equal to 5, equal to this entire equation, and then you would solve for x. But let's click enter on this on the calculator, and that gives us 9.592, and so that would be our answer. So 9.592, and it would be y is equal to, but actually your teacher might not accept y's, and you'd have to write the function name, because it's a function. So the y value up there, that'd be h of t. Then this would be h of t2, but we plugged in t for 1.3, so 1.3, that's equal to 9.592. That was our answer. So now moving on to the next one, we can clear that and go back to stat, and then we want to go up to what it actually to the L's, and then click clear. If it doesn't clear, then you just go down and then it'll clear. Do the same thing there, and then just fill in the table. Alright, we filled it in. Now alpha stat calculate. Oh wait, I completely forgot to read the first question. My bad, guys. So yeah, asking if it's a linear, quadratic, and cubic. Then from answering that, we would know which one to use over here. So when we're looking at this table right here, it's increasing, and then it looks like this is the max, and then it goes down again. So there's only one max. That means it's going to be another quadratic. It increases into a maximum and then starts decreasing. So it's like, a quadratic, it only has, looks like that. So it's quadratic because a of t increases to a max, and then decreases, and to the max, which is, you can say increases to max at t is equal to 19, or it's symmetric around t is equal to 19. So and now find the appropriate regression. Okay, so go down to number 5, quadratic regression, click enter. We can store the so alpha trace, we can store it with y2 if we want. If we want to keep the y1 just in case we get asked another question of it, and you can click y is equal to go back to see each equation, but it honestly doesn't really matter, but I'm just going to use y2. Now calculate, and then this is our values, so we're going to write that. This is a t. Alright, so that was our equation there. And now use C. Using a model found in Part B, what is the predicted price of one share of Amazon stock when T is equal to 16 months, which is April 6, 2021. So T in months, that's going to be the X up here. And so go to alpha trace to get that Y. Make sure to use Y2 because that's what we put in this function for. If you used Y1, then use Y1, whatever you used. Go to 16 months, which is going to give us 177. 16, T is equal to 16. That gave us 177.79. And this is in dollars. Looking back at this. So we can put the dollar sign up front. That would be our answer. Now D, the actual price for one share of the Amazon stock on April 6, 2021, which was T is equal to 16 months, was actually $168.61. So what is the residual? Residual right here. That was in the notes. I just put up a screenshot of what that meant. What is the residual for this value? So basically residual is basically you're just subtracting the true value with the value that you got. The true value is the actual value, which is right here. The actual price was 168, and minus what we got, which was 177 right there. And so using the formula, just subtract those two. So 168.61 cents, that was the actual value, minus predicted by the function, and then just put that in the calculator. So 168, oops, that gives us negative 9.18. So that should be our answer. So we're gonna do one last one. So honestly, reading the problem is probably unnecessary, but yeah. So this one right here is telling us the regression already, so that we don't have to figure out which kind of regression it is. And so yeah, it's telling us it's a cubic regression, so we don't have to figure out anything, but we can see it. It increases, then goes down, but then increases again. So you can see that's a cubic regression. So anyways, yeah, so we're gonna plug this into the calculator. I'm just gonna speed this up because by now you should know how to do it. Now alpha stat calc. Now we're gonna go down to number 6 because it's a cubic regression. We're gonna put alpha trace, and then we're gonna go to Y3 since we already used Y1 and Y2, but it doesn't really matter. It depends if you want to keep your other functions or not. So we're gonna write this down. That is RT. Alright, that's a little messy around the X's, but yeah. Now, based on the model found in Part A, what is the predicted federal funds rate for the year 2026, which is when T is equal to 8. Okay, so we're just plugging in T for 8. That's going to give us, so alpha trace to get Y. Y3 is what we used, so 8. That's going to be 52.357. So 52.357. And that's in percent. That's what it says there. So that would be our answer for that part. And now C. The highest federal fund in the U.S. history was 20% in 1980. Based on this information, the answer found in Part B, do you think the cubic regression model found in Part A is useful in predicting rates into the future? Explain your reasoning. So, based on the answer we got on Part B, so you can write that, we got 52, but 52, so I'm just gonna quickly write this, 52%, which is what we got, or write the entire thing, was way too large. So that was our answer found in Part B for the model RT. This was too large since we were told that 20% was the highest ever. Was the highest ever. So then our function here, regression function, wouldn't be that useful. So you can say something like, the answer found in part B for this cubic regression is not very useful because our part B answer, which was 52%, was too large since the highest ever was only at 20%. And so there's no way it could have gone to 52%. So it's probably like an answer like that. So these two questions you can try out for yourself. Number 4 was pretty easy. That one was a really quick one. Number 5, here it does ask why is it a linear regression model. And you can say that because remember, with linear is when it's roughly going up a constant rate of change. So answer why it's a linear regression, then you'd probably have to say something like it has roughly a constant rate of change, whatever that rate of change is. It's pretty constant. Remember, you can find the rate of change using 2 coordinates, and then something like that. And then you can also put it into the calculator. That was topic 1.13 and 1.14. So thank you so much for watching, and good luck.